Good morning, children. I hope you all are doing fine. Welcome to chemistry class again. I hope you remember what we studied yesterday. So we were talking about mixtures. We were talking about homogeneous mixture, heterogeneous mixture. We were also talking about how to separate these mixtures, right? We have simple physical methods to separate. We had other methods like evaporation method. We were also talking about immiscible liquids, how two liquids form two separate layers and how to separate them through separating funnel methods and all, right? And in the end, we had watch glasses. Remember, 3 watch glasses. We put 1 spoon of iodine and 1 spoon of salt and we mixed it together. We were speaking about how to separate this mixture, right? So today let's continue the same topic. So today let's see how to separate salt and iodine mixture. So method of separation of salt and iodine. Let's recall what we studied yesterday. So, some substances, when heated, change directly from solid to gas without changing into liquid state. So, what's happening here? There are some substances. They from solid, they do not go through liquid state but directly convert into gas state. Okay, and there are also some gases, when cooled down, they get converted into solid and not liquid. So let's say clouds. So clouds are in the gaseous state, right? But uh, because of some process, they become ice and then they fall as ice, as snow. So they do not go through the liquid state. So that is an example for gases becoming solid and not going through liquid state. Okay. So solid, when heated up, it becomes gas and do not melt down like ice. So they become gas. And gas, when cooled down, they become solid and they do not become liquid. They do not condense. So they become solid. So what is this called? We studied about this. No, these are called as sublimable substances. So what are the sublimable substances? The substances, when heated, change directly from solid to gas without changing into liquid state. So these are called as sublimable substances. Let's look into the examples of sublimable substances. Okay. First one is iodine. So iodine, when heated up, it becomes gas and not liquidified. Okay, so this is an example for sublimable substance. Also naphthalene. What are these naphthalene? These are mothballs. Remember, you keep all small white balls between your clothes so that moths don't come and eat up your clothes or destroy your clothes. So these are called as naphthalene balls. They convert directly into gas. You can smell it. It has a distinct smell, right? Also camphor. What is this camphor? It is called kapoor. So in the temples you used to light up a diya and all. So these are called as camphor. So these also are sublimable substances. They are solid and when you light them up they become gas. They have very distinct smell or fragrance, right? So these are sublimable substances. Also ammonium chloride. Even these are solid particles. They become gas instead of becoming liquid when heated up. Also, anthracene is another example for sublimable substances. So, these are the examples for sublimable substances. Okay. Now, what is sublimation? So, this is the word used for the sublimable substances. So, let's look into what is sublimation. So, some substances, when heated, change directly from solid to gas state without changing into liquid state, or vice versa. Gas becomes solid when cooled down. So, this whole process is called sublimation. What goes through this? Sublimable substances goes through sublimation. Okay. Now, let's look into a small experiment for sublimation. Okay. So, what are the materials required? We need iodine granules, we need salt, and then there's a Bunsen burner for the flame. Then you have a test tube, we need a funnel, and also a china dish. We already put the salt and iodine crystals back in yesterday, right? In a watch class. So, it's a similar experiment here. Let's see what the experiment is. So, we can see there's a Bunsen burner. We can see a china dish kept on the table. Now, what's happening here? We take 1 spoon of iodine granules. Okay, we take it and we put it into the china dish. And next, what are we doing? Now, we have salt. So what are we doing with the salt? We're taking 1 spoon of salt as well and then putting it into the same china dish. Okay, and now a funnel is kept on the china dish, and what's happening, there's a test tube but it is inverted. So we have a funnel and an inverted test tube is kept on the funnel. So what is the apparatus here? We have a Bunsen burner, we have a china dish, and in the china dish we have iodine and salt crystals, and then there is a funnel kept on the china dish, and there's an inverted test tube which is kept or which is placed on the funnel. Now we light up the Bunsen burner. So what's happening here? The flame is passing through the china dish, and thus it is passing through the iodine and salt. So can you see some vapors forming? See, you can see the vapors here, and then it is passing through the funnel into the test tube. So this vapors, instead of becoming the liquid, here you can see the gas states, right? So after solidification, after you pass it through flame or after you heat it up, it's becoming vapor. So which do you think is becoming vapor, iodine or salt? Yes, we just studied about the examples, no? So iodine, here what's happening, the iodine crystals, these are becoming gases. Okay, so you can see the gas formation here on the inverted test tube. Then once it cools down, let's see what's happening. You take the test tube and you can see these iodine crystals on the inverted test tube. So after the gas cools down, it again becomes solid, it does not liquidify, right? That is the sublimation process. So what's happening here, you have salt left behind, and the iodine, even after mixing thoroughly both iodine and salt, once it gets heated up, the iodine has become vapor or it has become gas, and then it went onto the inverted test tube, and then it has liquidified, not liquidified, it has condensified into solid. So you have iodine crystals on the inverted test tube. And when you remove the funnel, now you have salt, the remaining salt in the china dish. Okay, what did we do here? We separated iodine and salt mixture. How? Through sublimation process. Okay, so this is a small experiment used. So what is a condition for sublimation process? We saw how to do the sublimation process. Now we took salt and iodine. So what is a condition required here? Let's look into it. So it should be a solid mixture. Salt is also a solid, iodine is also a solid. So that's why it has to be a solid mixture for sublimation process. Do you think liquid and solid can be taken? No. Why? Because both of them go through the same state, right? Even the liquid will be vaporized. When the solid, which is sublimable, that is also vaporized. So we cannot take liquid and a solid. It has to be a solid mixture. One of the components in the mixture should be sublimable substance. So among iodine and salt, only iodine was the sublimable substance, right? NaCl become liquid, but the iodine becomes vapor. So one of them should be sublimable substance. If both of them are sublimable, both of them will vaporize. So there is no point, right? You cannot separate it. So one of them has to be sublimable substance, the other one has to be normal substance. So these are the conditions for sublimable process. Okay, I hope you understood. So let's look into a question now. How one can separate ammonium chloride from a mixture containing ammonium chloride and sodium chloride? So the option A is precipitation, option B is sublimation, option C is chromatography, option D is centrifugation. So you get 30 seconds of time. We just spoke about this, no? Think over it. How can you separate ammonium chloride from a mixture containing ammonium chloride and sodium chloride? You have 4 options. You have 15 seconds of time, children. You have 5 seconds left. 3, 2, 1. So what's the answer? Yes, you guessed it right. It is sublimation. So one can separate ammonium chloride from a mixture containing ammonium chloride and sodium chloride through sublimation process. Why? One of them, sodium chloride, does not become sublimation. It does not undergo sublimation, but ammonium chloride does undergo sublimation, and that is how you can separate this mixture. Okay. Now, do you think milk or cream or yogurt can be separated through the same process? Do you think cream has only milk component? Do you think it has some other components as well? What about yogurt? Does it have only curd component, or does it have cream and milk component in it? What about cheese? Do you think it's only made up of milk, or do you think there is some other things added to it? Let's see why we are talking about this, okay? So, is the dye in the black ink in a single color? So do you think the black ink is only made up of black dye, or do you think there are other dyes or the other dye components in the black ink? What do you think? When you write it down, it just appears as black, right? But do you think there are other components? Let's see. So you have a black dye kept in the jar or a beaker over there. So is the dye in black ink a single color? Do you think it's a single color, or do you think there are other certain colors added to the same dye? Let's look into it through an experiment. Okay, so we have a strip of filter paper here. We take a filter paper, and then there is a beaker kept. So in the beaker we have a little bit of water filled. Okay, there's a little bit of water in the beaker. Then we have a strip of filter paper. Let's see what they're up to. Now, like I said, it's a beaker, and we draw a mark, we draw a line on the filter paper, like 3 centimeter above from the bottom. Okay, from the bottom you take 3 centimeter and then mark a line on the filter paper. Next, what do we do? Like I said, draw a line on it using a pencil. Okay, use a pencil. Why not ink? Because then again ink will react to it, right? So you use a pencil to mark the line, and then we drop one small drop of ink on the line. Okay, you put a line 3 centimeter above the bottom, and then you put one drop of ink on that line. Okay, and then what do? We place it inside the beaker. So what's happening in the beaker? There's a little bit of water, and then you take the filter paper, you mark a line, you drop an ink, you put one drop of ink in it, and then you place that filter paper inside the beaker containing water. So what's happening here? Can you observe? See, there are different components of the ink that is separating out. So what's happening in the filter paper? Filter paper is absorbing water. So once it absorbs water, the ink also is absorbing water, and it is moving. It's moving above the filter paper, it's moving through the filter paper. And how? It is separating into different components. So we have blue component here, we have black in the bottom, we have red, and we have yellow. There are many other components, but for now we can see these components: black, blue, red, and yellow. So did you know that in just this black ink we have so many different dye components? We cannot notice that in the normal conditions, right? So the ink that we use has water as the solvent, and the dye is soluble in it. So the ink that we use in the normal day life, it has water components, it has water, and the dye is dissolved, or it is soluble in water. Okay, so as the water rises on the filter paper, so as the filter paper absorbs all the water, so when it absorbs, the water rises, right? The paper, so like I said, the water rises on the filter paper, it takes along with it the dye particles. So water takes along the dye particles with it, and that's why the dye particles keep moving along the filter paper. So generally dye is a mixture of one or more colors. So here we have 4 different colors. There might be many other colors, but for now we can see 4 different colors. So generally the black ink, black is very pure, very black, you cannot see any other color, and yet there are many different components there, many different dye components. So the dye which is more soluble in water dissolves first. So what's happening? Here you can see yellow is on the top. So what's happening? Yellow dissolves more in the water. So that dissolves first. So after dissolving, the dye which is more soluble in water dissolves first, and then it rises faster and separates into different colors. So yellow dissolves first and then it rises faster than the other components. Then comes red. So red then dissolves after yellow, then it rises to some extent, and then blue, that also dissolves in the water and rises to some extent. So all of these components dissolve in water, but some of them dissolve faster, some of them dissolve slower. The one which dissolves faster moves faster through the filter paper, and then the rest of them slower than that. That is why we see yellow on top, then comes red, then comes blue, and then the black. So this is how it gets separated. Because of this, because of water. Why? Because all of these soluble, all of these dyes are soluble in water. Okay. So what is this process called? This process is called chromatography. Okay, the process of separating out the dye components using water as solvent as an example. So this is called as chromatography. So this process of separation of components of a mixture is called chromatography. Chromatography is the technique used for separation of those solutes that dissolve in the same solvent. So all the dye particles or the dye components are all dissolved in the water. So they can all dissolve in water. So there are some cases where some of the components do not dissolve in the water. So that then you cannot use the chromatography technique. So all of the components all of those solutes need to be dissolved in the same solvent. You need to have a same solvent for all the solutes. So this is the condition for chromatography. So what is this chromatography? The process of separation of components of a mixture is called as chromatography. How? Through you have a same solvent, and then the solvent raises through filter paper, and because of which it gets separated out, right? So what is this chroma in chromatography? It is a Greek derived word. What does it call? It means color. So it's mainly used to separate colors, right? We just saw that dyes are separated, so that's why colors are usually separated through chromatography. This technique was first used for the separation of colors. Like I said, colors, many different colors are put in one, and then when they are put into the filter paper and then the same solvent is used, it gets separated accordingly. Okay, it depends on which dissolves first. So let's see what are the applications of this chromatography. Where do you think it's used? First thing is to separate colors, no? Where? In the dyes. So let's see. To separate colors in a dye. The dye like black ink so had so many other dyes, no? So it gets separated out. So this is one application. And also to separate pigments from natural colors. So natural colors may be from plants, maybe on animals. See in green how it's made from blue and yellow. So blue and yellow mix and becomes green. So in the same way, so this chromatography can be used to separate blue and yellow from green. Matlab it can be used in the plants to separate the natural pigments or natural colors from plants or animals or anything that is naturally derived. And also to separate drugs from blood. So maybe blood doesn't dissolve in the solvent first, and the drugs might dissolve faster. So in this way, to separate drugs from blood, same chromatography technique is used. The solvent could be different, it might not be water, but the technique is same. Okay, so these are the applications of chromatography. Now we studied about immiscible liquids, no? We had two separate layers formed between oil and water. But what about miscible liquids? What are miscible liquids? Miscible liquids are when both the liquids mix well together. So there are no separate layers formed. It is one single layer of liquids. So let's see, do you think we can use the same separating funnel method? No, right? Because it's in the same layer. There's no two different layers formed. So how to separate these miscible liquids? Let's look into method to separate a mixture of two miscible liquids. Okay. So what are these miscible liquids examples here? We have water and ethanol. So water and ethanol can be mixed together and they do not form two separate layers. They form single layer. Why? Because they are miscible liquids. They can mix well among themselves. Okay. So we put ethanol into water. So what's happening in the beaker? There is no separate layer formed. It's single layer. It has both water and ethanol mixture, right? So it is, you can see there are no separate layers formed. What is this? This is called miscible liquid. So how to separate this? Liquids that mix well with each other are called miscible liquids. Like I said, water and oil are not miscible. Why? They form two separate layers. They do not mix well with each other. They are called immiscible liquids. Here water and ethanol mix well with each other. So what are they called? They are called miscible liquids. So how do we separate miscible liquids? Let's see. We have an apparatus set up here. What are the components in the apparatus that you can see? We have a distillation flask here. Then we have a thermometer which is kept inside the distillation flask through the cork. And then we have a Bunsen burner. We have mixture of acetone and water inside the distillation flask, right? And then you can see a side tube here. So there's a tube that goes along till the end, and here acetone is formed, okay, and in between we have water condenser. So what is in the water condenser? There's cold water. Cold water comes inside, cold water goes outside. So this is coming, this is going. So what is this? It is a continuous flow of cold water, okay. So let's see how to separate it here. So you can see, once the Bunsen burner starts burning, the temperature is raised to some extent. To what extent? It's 57 degrees Celsius in the thermometer. So do you think ethanol and water boil at the same temperature? What's the boiling point of water? Yes, it is 100 degrees Celsius, right? But do you think it's the same for ethanol? No, ethanol's boiling point is 57 degrees Celsius, okay. So once the Bunsen burner starts burning, and then once the liquid gets warmed up inside the distillation flask, what's happening here? The temperature is raised to 57 degrees Celsius. So once it raises to 57 degrees Celsius, the ethanol in the mixture starts evaporating. Why? It starts boiling. Why? Because the boiling point of ethanol is 57 degrees Celsius. But does water boil? No. Why? Because boiling point of water is 100 degrees Celsius. So once the ethanol starts evaporating, once it starts boiling, it starts evaporating, no? So once it starts evaporating, it goes on top. So what's happening? It's in the gas state now, ethanol. So when it is in the gas state, it can pass through this pipe, no? It can pass through this tube. So when it starts passing through this tube, there is cold water over there. So what does this cold water do? It condenses. No, when gases are condensed, what happens? It becomes liquid state. So the ethanol, what is in the mixture, it becomes vapor when it is boiled at 57 degrees Celsius, and then when it passes through this tube, there's cold water. There's a continuous flow of cold water. What makes the gas condense? The cold water. So ethanol gas, then it condenses to liquid form, and then you can get the ethanol or the acetone here, right? So this is how you separate water and ethanol mixture. So ethanol and acetone are same thing. So the liquid acetone or ethanol is formed here, but water remains the same. Why? Because boiling point of water is 100 degrees Celsius. Like I said, 57. Then you can see there. So what is this process called? It is called distillation process, okay. Methods of separating miscible liquids. One of the liquid has lower boiling point, the other one has higher boiling point. The one with lower boiling point, it evaporates first, and then it goes through water column where there is continuous flow of cold water. So the gas which is formed, it condensifies to liquid, and then the pure liquid is formed on the other end. So you have water here, you have acetone or ethanol here. So that is how you separate miscible liquids. So what is this process called? It is called distillation process. So the method used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points is called distillation. So there is difference in the boiling points. No, water is 100 and the ethanol is 56 or 57 degrees Celsius. So there has to be difference in the boiling point, and it does not undergo decomposition. So this method of separation of components of a mixture with, it's a miscible liquid. Two liquids are used here, and there is difference in the boiling point. So this method is called distillation method. Okay. So to separate a mixture of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin, fractional distillation process is used. So what's happening, there are two miscible liquids and the difference between them is less than 25 degrees Celsius. When that is the case, see, it's in water and ethanol, it was 157 degrees Celsius, no? But when it's less than 25 degrees Celsius, fractional distillation process is used. It is similar to distillation but a little different from that. So this is the definition of distillation. Okay, I hope you all understood. Fractional distillation is when the difference is 25 degrees Celsius or less than that. That is when you use fractional distillation process. I hope it's clear, children. Let's look into one question. Okay, so common method used to separate dyes. We just spoke about this earlier. So what is the common method used to separate dyes? A. Distillation process. B. Chromatography. C. Filtration. D. Sublimation. So I give you 30 seconds of time. This time starts now. I'm sure this is very easy. What's the common method used to separate dyes? Is it distillation or chromatography or filtration or sublimation? You have 15 seconds of time. I'm sure you all have guessed it already, right? You have 5, 3, and it's done. So what's the answer? Yes, dyes, how are they separated? It is through chromatography process. Okay, the common method used to separate dye is chromatography process. Now let's move on to fractional distillation. Let's see how fractional distillation usually takes place. We just saw how normal distillation process takes place, no? Now let's look into fractional distillation. So this is a little bigger apparatus. Don't break your heads. It's very easy. So you have the same, a little bit same of the apparatus. So we have the same distillation flask here. There's a mixture of miscible liquid. There's again the same Bunsen burner. We have just the holder, and this is the fractionating column. So in this fractionating column we can see some bubbles, no? These are glass bubbles, okay? And then we have cork. The thermometer is placed on the cork. Again we see the same setup. We have the same tube. We have a water condenser. There's a cold water, and then water comes in, water goes out. The same thing. So this is continuous flow of water, and then you have pure liquid component here. From the mixture we get pure liquid component. So it's the same process again. So here a simple fractionating column is a tube packed with glass beads. So those bubbles you can see, these are called glass beads. So these beads provide surface for the vapors to cool and condense repeatedly as shown in the picture. So the mixture here, there is mixture. Once it starts warming because of the Bunsen burner flame, it becomes vapor. One of them becomes vapor. What's the distillation condition? Only one. They have difference in the boiling point, no? But there's very less difference. There's only 25 degrees Celsius or less. So when that is the case, we have these beads kept. What are these beads doing? They help the gases to condense and cool rapidly and repeatedly. So once they condense and cool, they pass through this column, and this column again has flowing water through it. So when there's flowing water, what happens? The gas condenses into liquid. So once gas condenses into liquid, and then the final product is this, the pure component. So from the mixture we get pure component. It's the same process how we used in the normal distillation process. In the fractional distillation you just have these glass beads. Why the glass beads? Because there's a very less difference in the temperature between the two liquids, no? So this is how you do fractional distillation. Okay, now the distillation process. What's happening here? Let's see the application of distillation. Where do you think this distillation is used? Well, the normal method is to separate the miscible liquids. But where do you find these miscible liquids in the daily life? Let's see the applications. So, it is used to separate different gases from air. Okay, you have air has a lot of different gases, maybe carbon dioxide, maybe oxygen, maybe nitrogen. We cannot separate them through normal conditions. So distillation process is used to separate different gases from air. Okay, and then separation of different fractions from petroleum product. So you have petroleum product, there is kerosene, there is diesel, and then how to separate them? There is the distillation column. We'll study about this further, but for now there's a distillation column, and then once the same process goes through, and then all the petroleum products get settled down on the different parts. So once there's boiling, the Bunsen burner is boiling, the mixture is boiling, one gas goes, condenses, and then you get one product. Then the next gas, next product, next gas, next product. That's how you fractions of petroleum product is separated out. So this process is called distillation process. Okay, there's fractional distillation, there's normal distillation. So I hope you understood everything here. The apparatus is easy, the process is easy. Okay, now let's look into some more things about the same. So what do we see here? We see two friends flying kite, no? So where they are flying? They're flying in the nature, and where the kite is flying, it's flying in the air. So air has many different components. Like I said, air has carbon dioxide, air has the oxygen, air has nitrogen. So it is a homogeneous mixture, right? All these things are mixture, but it is a homogeneous mixture. All of them are mixed well among themselves. Okay, so air is a homogeneous mixture. And how to separate the gases from the air? How to separate this oxygen, this nitrogen, this argon, and all these different gases that are in the air? How to separate them? Let's see. So it can be separated into its components by fractional distillation. We studied about this just now, the applications. So we separate gases in the air. So how are these gases separated? Through fractional distillation. Let's see. So air, what's happening here? So air is compressed and cooled by increasing pressure and decreasing the temperature. So how do you compress air? By increasing the pressure. And how do you cool it? How do you cool the air? By decreasing the temperature, right? So this is the first process. So you take air, you compress, you apply pressure, you compress the air, and you decrease the temperature, so air is cooled down. So what happens when the air is cooled down? It is liquidified. So now you have liquid air. First you had it in the gaseous form, it is compressed and cooled, then you have liquid air. Okay, and then you allow it to warm up. So you turn on the Bunsen burner, so it warms up slowly. Okay, so where? In the fractional distillation column. So you have air, it is compressed and the temperature is reduced. What happens? You get liquid air. So this liquid air is allowed to warm up very slowly. Where? In the fractional distillation column. So the same column is used here. And then what happens? The gases get separated at different heights. So one gas has different boiling point, the other gas has different boiling point. So once the one with lower boiling point evaporates first, and then the other ones. So what's happening? Air, you compress, you decrease the temperature. Liquid air, you warm it up. So what happens? The gases get separated at different heights. Okay. Now these are the normally present gases in the air. So which are those? It's oxygen, there's argon, there's nitrogen. So look into the boiling point here. There's difference in the boiling point, but not much, right? So the oxygen's boiling point is minus 183 degrees Celsius, but whereas the argon's boiling point is minus 186 degrees Celsius. There's only 3 degrees Celsius difference. And also the nitrogen has minus 196 degrees Celsius. All of these are below 25 degrees Celsius among themselves. No, there's oxygen, argon and nitrogen. These are the common gases present in the air. Then what is the percentage of air by volume? So oxygen in the air is only 20%, 20.9%, and then the argon is 0.9%, and the nitrogen is 78.1%. So even after being 78.1%, there's difference in the boiling point. You can see the difference, no? So this is, because of this difference, you can separate them through what? Through fractional distillation. Now let's look into one question, okay, before continuing this. So what are the different components that can be separated from petroleum by A. Filtration, B. Chromatography, C. Simple distillation, D. Fractional distillation. Again you get 30 seconds of time. Think it over. Different components can be separated from petroleum by The petroleum products can be separated through what? A. Filtration, B. chromatography, C. Simple distillation, and D. Fractional distillation. You have 15 seconds of time left. And now 10, 5 seconds, 4, 3, and time's up. So did you guess the right answer? I hope you did. The answer is fractional distillation. We spoke about this just a while ago. So different components can be separated from petroleum by fractional distillation. Okay, I hope you all have guessed the same answer. So now you can see an apparatus here. So what do we have? So we have filter. So air is passing through this filter, and there, like I said, air is passing, and then it is being compressed here. No, air is being compressed, and then the temperature is reduced there. Air is compressed, the air is under pressure, and then it passes through another column. What's happening? There's hot air. Why? The temperature is changed now because of the pressure. So there's hot air, then it goes through another column. So what's happening here? Freezing cold water is passed through this column. So the hot air passed through this column where there is freezing cold water. There's a continuous flow of water there, and then water in, and through up the water goes out. So there's continuous flow of water. And now what's happening? We have cold air now. This cold and compressed air. Once the pressure is increased, the air gets warmed up. No, so there's hot air, and then it passes through water. The flow, continuous flow of water. So what happens there? There's a cold compressed air when after it passing through water. So then it goes through another column. So what happens in the next column? There's a separator. So what does it separate? It separates out the carbon dioxide as dry ice. So the carbon dioxide is passed out as dry ice through the separator after cold compressed air. Then the other components are passed through another column. So what happens in this column? Let's see. Now the air is liquidified. So you have liquid air. Once the air is cold compressed, we saw the liquid air no in the before the flow chart. So the same liquid air is here in the next column. So there's an expansion jet. So what happens in the expansion jet? All these are separated out. So next is the fractional distillation column. So once the expansion jet is open, the liquid air goes through fractional distillation column, and the same process takes place. It gets boiled out, and then different gases are separated out. Okay. So liquid oxygen is formed. So the whole process was for the liquid oxygen. So there's filter, the air passes through some column, and then there is the increase in the pressure. So air is under pressure, so it becomes hot. So the hot air is then passed through some other column where there's a continuous flow of cold water, because of which the air is compressed and cold now. So after that it passes through a separator where carbon dioxide is first removed. So after the separator, there's a liquid air now. So the liquid air passes through an expansion jet. From there the expansion jet opens up, and then it passes through a fractional distillation column. Here what happens? The oxygen is then warmed up. Through the distillation process you get liquid oxygen. Okay, so this is the process. I hope you all understood this process. Let's continue the further topics in the next class. Bye children, have a good day.